We think of viruses as unkind creatures which cause unpleasant, if not fatal, illnesses.
But what if I told you that not all viruses are out to get us? In fact, we may be able to use a certain type of virus to our advantage. The bacteriophage, also known as phage, is a type of virus which only kills bacteria.
The phage population surpasses that of all organisms combined. Phages exist anywhere bacteria are found.
Each phage species is designated to hunt a single type of bacteria and possibly a few other similar strains. Phages also kill bacteria which cause disease in humans.
Of course, antibiotics work effectively to treat many bacterial infections. However, some strains of bacteria have developed resistance against antibiotics because they were prescribed abundantly for unnecessary reasons, such as viral infections.
This gave bacteria the exposure to start evolving to defend themselves against antibiotics, and there are already some strains of bacteria which have developed resistance to all antibiotics available. They are called superbugs.
But phages can play an important role in the effort to combat antibiotic resistance.
Superbugs which are resistant to antibiotics are still vulnerable to phages. Since phages target one specific type of bacteria, they can wipe out the infectious bacteria in a patient while leaving beneficial bacteria. Phages can be administered intravenously, topically, even through pills.
And as the most plentiful entities on the planet, bacteriophages are easily accessible from the environment.
Phages end a bacterial infection with a two-step process. First, injecting their DNA into the bacteria, which then results in the production of phages instead of more bacteria, halting the spread of infection. Once the bacteria are full of newly formed phages, they will rupture, bursting out the newly formed phages and dying, clearing the infection. Can a superbug gain resistance to phages? Yes, but then bacteriophages evolve too, so phages can adapt to bacterial defenses. However, while bacteria gain defense mechanisms to combat phages, a protective layer around them called a biofilm degrades, leaving them once again vulnerable to antibiotics.
In this case, we can bring antibiotics back into the game and use them along with bacteriophages to treat bacterial infections. Phage therapy is considered experimental in the US, but it is an accepted form of treatment in a few European countries and has also been used as a last resort treatment in some other countries.
There have been a number of documented successful cases of phage therapy for treating superbug bacterial infections such as Pseudomonas aeruginosa, Acinetobacter baumannii, and Staphylococcus aureus.
Bacteriophages are emerging to be a critical tool in combating antibiotic resistance.